Welcome to Crosslight's TCAD tutorial on Mixed Cylindrical Coordinate systems. Today I'm going to show you how to make cut lines on a racetrack structure. Crosslight uses cut planes for C-supreme 3D simulation. This means the structure will be cut into 5 planes in the Z direction. For example, in a FinFET structure, 5 cut lines should be defined for a 3D simulation. The structure will be cut into 2D 5 mesh planes with respect to these cut lines. Let's take a look at these planes without connection. This method will greatly reduce the mesh required for 3D simulation and improve simulation speed. When it comes to this structure, we use the same method for 3D simulation, but we can't simply just make cuts in the Z direction. We need different cut lines along the racetrack. Therefore, we developed a new method to generate cut lines for the structure. Now I'll introduce how to make different types of cuts. There are 2 methods here. The first one I'll talk about is a straight cut. This is a polygon. We call it a block. Imagine this block as a racetrack. This is the start line, and this is the finish line. And this is the total distance between them. Walking down the track, this is your left-hand side, and this is your right-hand side. First, we need to define the initial reference point and the initial cut angle. Let's take the origin as the starting point, or the initial reference point. The parameter start left xy is used to define the initial reference point. The initial cut angle is the angle between the start line and the x-axis. In this case, the start line and x-axis are coincident, so the initial cut angle is 0. In this method, the reference point and reference angle are not fixed. If you were to go straight forward in this direction, the reference point would move in the same direction. For example, if you move from the start line to this point, the initial reference point will move from here to here. The distance between the left boundary and the reference point is called the left side. Similarly, the distance between the right boundary and the right reference point is defined as the right side. Now, let's define the left and right boundaries of this block. These are the start points, and these are the finish points. For the left boundary, the left side of the start point is 2 microns. At the finish line, the left side is still 2 microns. Therefore, the left side can be defined as left side from is 2, and left side to is 2. For the right boundary, the right side of the starting point is 3 microns. The right side of the finish line is 6 microns. Now, the right side can be defined as right side from is 3, and right side to is 6. To define a cut line on this block, we use the distance between the cut line and the given start line. The cut distance here is 5. If you wanted to cut 5 equidistant cut lines on this block, you would use a cut distance number. In this case, it would be 5, including the start and the finish line. The second method I'm going to talk about is cylindrical cutting. This is a circular block. We need to define some cut lines on the blocks, such as these. Pretend this block is a track, where you're going counterclockwise. The inner circle is your left-hand side, and the outer circle is your right-hand side. The total angle between the start and the finish line is 90 degrees. First, we need to define the initial cut point. and the initial angle. Let's use the origin as the initial reference point. The initial cut angle between the start and the x-axis is 0. In a cylindrical cut, the center of the circle should also be defined. Shift origin is used to define the distance between the center of the circle and the initial reference point. If the shift origin was positive, the center of the circle would be to the right of the initial reference point. Similarly, if the shift origin was negative, the center of the circle would be to the left of the initial reference point. In this case, the center of the circle and the initial reference point are coincident. Therefore, the shift origin is 0. As learned before, the distance between the left boundary and the reference point is called the left side, and the distance between the right boundary and the reference point is called the right side. Now let's define the left and right boundaries of this block. These are the starting points, and these are the finishing points. The left side at the starting point is 4 microns, and the left side at the end point is also 4 microns. For the right boundary, the right side is 6 microns at both the starting and ending points. Here and here. Therefore, the left boundary can be defined as left side from is 4 and left side to is 4. And the right side can be defined as right side from is 6 and right side to is 6. Now let me show you how to define a cut line on this block. To define a cut line, we need the angle between the start line and the cut line. This is called the cut angle. The cut angle number is used to define equi-angle cut lines on this block. Let's summarize the cylindrical cut. When making cut lines for a structure, the structure needs to have multiple blocks. As you move along the track, the reference point and reference angle will change, but the initial reference point and initial angle are unique. You need to define the start line XY and initial cut angle before making a cut line for the first block. We usually take the starting point of the left boundary as our start line XY. The cut angle is the angle between the x-axis and the start line. Going along the track, a new block should be defined for every turn that we make. Now let's head back to the example. I'll show you how to make different cut lines on this structure, mixing in some cylindrical cuts. To be clear, only counterclockwise is supported in making cylindrical cuts. The starting line should be the vertical line instead of the horizontal line. To define the cut lines, we need to first define the initial reference point and the initial cut angle. I'll use the left boundary as the start left XY. So we have 249 and 0. Since the start line is perpendicular to the x-axis, the initial cut angle is 90. Starting on the start line, you're going to first make a turn at this point. Therefore, this is the first block. Let's define cut lines for the first block. We can use straight cut for this. The total distance between the start and the finish line is 249 microns. Since the reference point is on the left boundary, the left side from is 0, and the left side to is 0. The right side is the distance between this point and this point, which is 615 microns from and to. I'm going to define 4 cut lines along this block with a cut distance of first 15 microns, next 100 microns, 150, and finally 200 microns. We've defined 4 cut lines on this block with a fake cut line on either side. This is because the start and finish lines are defaults. Moving along the track, this is the next time you're going to make a turn. Therefore, this is the second block. Let's define its cut lines. For this block, we need to use cylindrical cut. The total angle is the angle between this line and this line, which is 90 degrees. The shift origin is the difference between the center and the original reference point. In this case, the center of the circle and the initial reference point are coincident, so the shift origin is 0. The left side from is 0, and the left side to is 0. The right side from is 615 microns, and the right side to is also 615 microns. I'm going to define 2 cut lines with an angle of 30 degrees and another one with an angle of 60 degrees. This is the 30-degree cut line, and this is the 60-degree cut line. Again, the beginning cut line and the finishing cut line are defaults. For the last block, we'll use straight cut again to make 3 cut lines. The total distance is 249 microns. The left side from is 0 and the left side to is 0. The right side from is 615 and the right side to is also 615. Its cut distance number is 6. 6 cut lines will be generated on this third block. And here they are. This concludes the definition of cut lines on this structure. This is the outcome of the structure after simulation in 3D Supreme. These are the cut lines we got using the cylindrical cuts. And this here is the net doping distribution. Thank you for watching Crosslight's TCAD tutorial on Mixed Cylindrical Coordinate Systems. We hope to see you in another one of our tutorials.